So this is section 2.6, talking about related rates. So here's the idea. We just finished talking about implicit differentiation. So if we were going to do our implicit differentiation for this equation, and we wanted to do it like with respect to y, let's just quick review. How would that go? Well, so we take the derivative of the left side, and that would be, or no, taking the derivative with respect to x. That's what we normally do. We take the derivative with respect to x. So if we took this derivative with respect to x, we would do our normal, take the derivative of y with respect to x. And then remember how we talked about here, when we take the derivative of x, it's like we're taking the derivative of x with respect to x, but that's why the dx over dx, those are just canceling and just going away. And so here, so like implicit differentiation ideas, we just get dy dx equals 2x. And so the idea is here, we're using that same implicit differentiation ideas. We're just doing it with respect to t. So we're going to start with the same equation, and we're going to take the derivative with respect to t. So notice here, we're really doing the same things, taking the derivative of y with respect to t. Take the derivative of x, but we're taking the derivative of x with respect to t. So this time it's not just going away and canceling out. So now we have this equation, and it's just set up, this problem is set up to where they give us all these things. So they want us to find dy dt, they want us to find the left side when x equals 1, dx dt is 2, oh yeah, when x equals 1. Right, because dx dt changes depending on what x is. But based on the problem that's written, they have to be telling us when x equals 1. And so there we go. That's just 4. So that was a simple example, but these get a bit more complicated as you go down. So the next one is talking about it as a word problem, which already makes it a little more complicated. So a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. So if you didn't know what concentric circles means, this should tell you, because that's what the ripples are going to look like. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. So when we do these, I like to write down everything we know. So what do we know there? We know that the radius is changing. Oh my gosh, did my pencil die? All right, we're back. Pencil sharpened, ready to go. So where were we? The radius of the outer ripple is increasing at a rate of 1 feet per second. When the radius is 4, what is the rate? At what rate is the total area of the disturbed water changing? Right. So the ripple is changing at a constant rate, and we're thinking about the area. So I'm going to start with the area equation, A equals pi r squared, and then we got to write down what we know. So this is what we were doing when the pencil died. So they tell us that it's increasing at a constant rate of 1 foot per second. So that's our dr, the change in the radius, per change in time. So the dr dt is 1, positive 1, because it's increasing at 1 per second. So now we want to put that in our equation, but of course before we put that in the equation, we need to take the derivative so that's actually in the equation. But we're not taking the derivative with respect to a, or with x, like normal, or with r, we're taking the derivative with respect to t. So we're going to say take the derivative of a with respect to t equals 2 pi r, standard power rule, but then the derivative of r, so times dr dt. And there we go. So sometimes I'll write this too, what they want when the radius is 4, and then they want us to tell them at what rate is the total area changing. So they want dA dt. And so I think it is nice to set all this up, because now it's pretty simple to just plug everything in. The dA dt is our unknown. That's what we want. And that equals 2 pi. The radius, what we want when the radius is 4. And it changes dr dt is 1. So 8 pi. So the area changes by 8 pi when the radius is 4. Beautiful. I always did find these problems, even when I was a student. I thought these problems were pretty fun. So let's see the next one. So you got to know a lot of formulas for here. This is probably why I know a lot of volume formulas. So air is pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2. So let's write down what we know. So air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. So the units are another hint of what that is, but they're saying the air is being pumped in like that. So that's the volume. The change in volume per change in time is 4.5. What else? So they want it, so find the rate of change of the radius. So they want dr dt equals question mark when r is 2. All right, so there's everything we know, everything we want. So let's set up the formula now. So what is the formula for the volume of a sphere? Well, I know it. It's 4/3 pi r cubed. So now we're going to take the derivative with respect to t. So dv dt is, see, the 3 cancels, so 4 pi r squared times the derivative of r, so dr dt. And now we plug in what we know. So I guess this one's kind of interesting because look how it's the dr dt that we want. So what we actually want to do, we can plug in first or do this now, is we want to divide by everything. So now the dr dt is by itself. So then what we want is dv dt, which is 4.5, over 4 pi r squared, so times 4. So what is that then? 9 over 32 pi? I guess we do units, feet per second. So that's a pretty dirty answer, but I think that's pretty good. Alright, so here's the next example. An airplane is flying on a flight path that will take it directly over a radar tracking station, as shown in the picture. If s is decreasing at a rate of 400 miles per hour when s is 10, what is the speed of the plane? Is the speed not 10? Or s not the speed? No. So I guess we'd always think we got 2 things we need to write down. We need to write down our equation, and then we need to write down the things that we know. So our equation here is a right triangle. So it's 6 squared plus x squared equals s squared. I hate the letter s, but it's there, so we'll use it. So that's our equation. Now let's write down the things we know. So it says that s is decreasing at a rate of 400 miles per hour. So s, or I should say the change in s, so ds dt, is decreasing at 400 miles per hour. So negative 400. And then they tell us that we want when s is 10. And what do we want? The speed of the plane. So what's the speed of the plane? Well, it looks like the plane is going this way. So dx dt is going to be changing at a certain rate. But we don't just want dx dt because that's going to be negative because it's getting smaller. So what we actually want is the absolute value of ds dt. So that's just to remind us to absolute value it at the end. But that's not going to come into play when we actually do it. To actually do it, we just got to do it. Except for, wait, we don't want, it's not ds dt, it's dx dt. Right, because that's the horizontal portion of it. Right, so now we're going to take the derivative. So 6 squared, don't try to use power rule there because it's just a 6, it's a constant. So that just goes away. So it's 2x, change in x over change in time, dx dt, equals 2s ds dt. And then now we can just plug in what we want to know, right? So ds dt is negative 400, and s is 10. So 2 times 10 times negative 400 equals 2 times x. Right. And so they don't tell us the x, but they don't tell us the x because we can find it. Because if that's 10 and we know this is 6, we can use Pythagorean theorem to find the other side. Or triples, so that has to be an 8. So x is 8. I'll add that to the list of things we know. So we have 2 times 8 times the thing we're looking for, dx dt, equals all of that. So now, to solve for dx dt, we're just got to divide by 2 times 8. So we'll cancel. So it should be negative 500. So notice again, dx dt is negative 500. So this length here is getting smaller at 500. What is that, miles per hour, I guess? Yeah. So that's getting smaller at 500 miles per hour, which means the plane is moving that way 500 miles per hour. Yeah, that makes sense. That makes sense. And like we said at the beginning, it's the absolute value, so it just becomes positive. All right, good stuff. Got a few more. Got more than a few more, it looks like. So let's go to here. So again, same with all of these. That's why I like these. They're kind of the same, but they're all thinkers. So you got to set up the equation, or just use the one they give you, and then write down all the things you know. So they don't actually tell us anything in the question, which is annoying. But find the rate of change. Well, I guess they do. Find the rate of change in the angle of elevation of the camera. So the angle of elevation of the camera, see how that's your theta. So we want to know how theta changes over time. That's what we want to know. That's a question mark. I'm also failing at writing t's right now. I want to put the curve at the bottom, not the top and the bottom. So that's what we want to know. 10 seconds after liftoff. Whoa. Okay. What is S? Well, S is the height. Oh, and then they give you this equation here. S equals 50t squared. Oh, that's interesting. So maybe we do this differently. We just want to do this substitution right at the beginning. Because then if we're taking the derivative with respect to t, we won't even have to do our dt's over there. Because it'll be dt over dt. And just like the dx over dx, that's just going to cancel. So go ahead and simplify this. And then if I take the derivative of tangent is secant squared of theta, d theta dt, equals t over 20. And you don't need the dt dt. Yeah, that's fair. That's fair. So you can do that substitution beforehand because your s is a function of t. And then you don't have the dt dt because dt dt is just 1. So now, to solve for d theta dt, we just got to divide both sides by secant squared, which is also the same as multiplying both sides by cosine squared of theta. But what's the theta, you may ask? I may ask that as well. So we must find that theta by using that tangent equation. So we need to find the distance that it's actually gone up in that 10 seconds still. That still does matter. So how far has it gone up in that 10 seconds? Well, we just use that equation. So it's 10 squared times 50. So it's 100 times 50. So it's 5,000. So this height is 5,000. And actually, I would just keep going because we want the cosine. So it'd be nice then if we had this, we could get perfect answers. So what's that? That's the square root of 2,000 squared plus 5,000 squared. Which is what? So 4 with 6 zeros plus 25 with 6 zeros. So that's 29 with 6 zeros. So that's square root of that. So that's 1,000 root 29. Oh, yeah, obviously. Yeah. So that side's 1,000 root 29. And I just wanted to do that. So now if I'm trying to find the cosine of that angle. So I don't actually need to find the angle, because I just need the cosine. And the cosine is 2,000 over that. So this is 2,000 over 1,000 root 29. And all of that is squared. So that's going to cancel, just leave the 2 up here. So that's going to be 4 over 29. And that should be the answer. That was kind of a lot. I want to look back at the calc textbook and see if they agree. What? I got that one right. I got that one right. This one I screwed up. I missed a 2 somewhere. Was that just in a power rule? Oh, I didn't divide by 20. Well, that's even more problems then. Because then I should be dividing by 20. Oh, my pencil died too. Oh no. What's happening? Alright, I figured out what was wrong. You see, I had to redo the problem to figure out what was wrong. But the problem was I wasn't done with the problem. So what I found was I found cosine squared. That's cosine squared. And I'm still... the t over 20 is still there. And I kind of realized that, but I was like, oh, I'm not dividing by 20. I'm dividing by 2. How do you get the divide by 2? Well, that's because the t equals 10. It's 10 seconds after liftoff. So that's 10 over 20 times 4 over 29, which is how you get that to cancel the 2, which is how you get that to cancel, which is why it's 2 over 29. So that got me extra scared because we did it a different way than the textbook did it. But I was confident I did it right, and I was. I just wasn't finishing the problem. Beautiful. On to the next one. So, little engineeringness. So, in the engine shown in figure 2.38, a 7-inch connecting rod is fastened to a crank with a radius of 3 inches. Luckily, they draw it out, because I don't know what any of these words mean. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. Okay, so revolutions per minute. That's interesting, but it's in angle, so I feel like we should do angle. So I would say, I would do a little dimensional analysis. I'd say it's going at 2 revs per minute, but we really want it in angles. So in 1 revolution, how many angles are there? 1 revolution is 2 pi radians. So I just feel like that's better that we know it's going. That is going hecka fast. 400 pi radians per minute. That's a lot of radians. But okay, so what is that? That's how our angle is changing. And so just notice that like our angles, I didn't want our angle in revolutions. I wanted our angles in radians. So now our angle is in radians. So where can we go from there? Find the velocity of the piston when theta is pi over 3. So we're going to do theta is pi over 3. We've already said that d theta dt is 400 pi. And then we want the velocity of the piston. So notice how that's the x. So basically we want how that x density is going to change. We want dx dt. And, all right, we don't know the x because it's not necessarily a right triangle. Except when it's pi over 3, they're telling us it's a right triangle. It's not a right triangle when it's pi over 3, though. But hopefully we don't need that. Because what do we need? We just need an equation that relates the 2 variables we don't know. We need an equation that relates theta and x. So I might as well do sine, I suppose. Just use the equation that the sine of theta is opposite over hypotenuse, 7 over x. And I think that's fair enough. Now you take the derivative of both sides. So derivative of sine is cosine, but then d theta dt. And then 7 over x. So you could do like power rule there. But I think it's worth knowing that the derivative of 1 over x is negative 1 over x squared. So the derivative of 7 over x is negative 7 over x squared. And then times dx dt. Right, so just normal implicit differentiation with respect to t. So, yeah, pi over 3, that is 60 degrees. Very nice. So now, but we don't need degrees. Degrees are for wimps. Radians all the way. So now, we just got to plug in what we know. So we know that the theta is pi over 3, so the cosine of pi over 3 times 400 pi equals negative 7 over x squared. So x is the thing that we're unsure about. So we need to find this x. We need to find what that x equals. And you just see we know that because like our answer still has x in it. Like this is the thing we're solving for, dx dt. But we can't have the x in there. So we have to solve for x. And so it sure as heck looks like we can do Pythagorean theorem because that looks like a 90 degrees. But you know it's not if this is pi over 3 and you don't have like square root nonsense going on. So it might be close, but we've got to use trig stuff to find what x is. But we can do that just fine. So hopefully we get a calculator here. So as we can set up, we can actually just use this equation here that we started with. Sine of theta is 7 over x. So then we can do the sine of pi over 3 equals 7 over x because we know the sine of pi over 3. The sine of pi over 3 is root 3 over 2 equals 7 over x. So now we know that x is 14 over root 3. That's beautiful. So now we can plug that in here. So we have the cosine of pi over 3, which is 1/2 times 400 pi equals, let's see, we're going to square it. So negative 7 over 169 over 3. And by 169, I mean 196. Right, so I mean, that's going to be super dirty of an answer. And what does this equal? The thing we want? So then now to get it, well, I'll just go ahead and simplify that. So we'll have 200 pi, but then we have to multiply by 196 over 3. And then we have to divide by negative 7. So I guess I should have made this still 14 times 14. Because now we're going to cancel one of those and make that a 2. We still have the other one, though. So we've got 28 times 2, 56, 2 zeros with a pi, over 3. And negative, well, let's say, does that make sense? That is going to be going backwards? I guess. Let's check our answer. Negative 5600 pi over 3. Oh no. What? My root 3 went away because I squared it. Hang on. Alright, I don't know why I got that problem wrong. I'm just going to start over again. So I think I was just trying to go too quick. I think that was why I got it wrong. So what can I do? Well, I can write equations. So an equation that I know is I know that sine of theta equals 7 over x. No, I don't know that because it's not a right triangle. I don't know that because it's not a right triangle. Well, they don't want me to use, well, it's also angle side side. So should I use like the law of cosines? Do I really need to use the law of cosines right here? Are you serious? What is the law of cosines? The law of cosines starts off like Pythagorean theorem, c squared equals a squared plus b squared, but then minus 2ab cosine of theta. And so what are the things that we know? I mean, that's just another equation we could probably use, right? So now we're talking about, well, this is C, and we don't know that angle C. So do I need to use this? Well, no, I can find that angle C by using law of sines. I feel like I'm going to do this way too hard now. So I'm going to do law of sines. I'm going to say that sine of theta over 7 is the sine of this angle over 3. And I know that this is pi over 3. So I know the sine of pi over 3, so I know this is root 3 over 14. And then times 3 is equal to the sine of y. So the sine of y equals that. Well, then can I do the sine of y over 3 equals the sine, this is bad. So you gotta say the sine of Alright, I need a hint. I need to see, because I know this is going to do it, but I don't want to have you all go down crazy lines. They do want you to do that. And then they want you to take the derivative of that. Wow. Okay. So they do want you to do this, and they want you to plug in the stuff that you want to plug in. So I'd say we should use the angle we care about as our angle. But that means this is just going to be 7 squared, because that angle is always across. It corresponds to the side across from it. So 7 squared equals 3 squared plus x squared minus 2ab cosine theta. But what are a and b? A and b are 3 and 7. Well, no. A and b are 3 and x. So this is 6x. Oh my goodness. I mean, this is the last problem, so I guess that makes sense. So now it's like this is the equation we're dealing with, our law of cosines equation. And then we have to take the derivative of that using differentials. So you get a derivative with respect to t. So you get 0 equals 0 plus 2x dx dt. And then here you got to use quotient product rule. So the derivative of the first is 6 dx dt times cosine of theta. And then minus, because you got to distribute the negative. So minus 6x times the derivative of cosine, which is negative sine of theta. And then d theta dt. And so again, what do we know? So we calculate. It's like we calculated last time, that if we're doing 200 revolutions per minute, it's 2 pi radians per revolution. So that means you're doing 400 pi radians per minute. That should be our d theta. So let's write that down. That d theta dt is 400 pi. What else do we need? We need theta. Theta is pi over 3. What else do we need? We need x. And that's the whole problem, is that we need x. And so how are we going to solve for x? Let's again look back and see what they did. Oh, you can just plug it into the original equation that you wrote? Oh, yeah, because you're using that angle now. Right. So we're going to use this equation, and we're going to say that 49 equals 9 plus x squared minus 6x times the cosine of pi over 3, which is 1/2. So then I get x squared, move it all to the same side. So x squared minus 3x minus 40. That works. Equals 0. So then you factor, and that's x minus 8, x plus 5. So we get x equals 8 or negative 5. And you would know that's your ambiguous case because it could be like that or something. So we got to choose the positive one. We got to choose the 8, obviously. So this is 8. So now we know that x is 8. And so now we can plug everything into here that we need. So let's use a different color. So this is 2 times 8, 16 dx dt minus 6 times dx dt times the cosine of pi over 3, which is 1/2, plus 6 times x, which is 8, so 54, sine of theta, sine of pi over 3 is root 3 over 2, times d theta dt, which they told us was 400 pi. And 0 equals all of that. So now I'm just going to do that, call that 3. So I'll call that 13 dx dt. Move everything else to the other side. So I guess we'll go ahead and cancel. So I'll get 10 800 root 3 pi. And then I just have to divide that by 13. I thought that was more complicated last time, but that makes sense. 10 800 root 3 over 13. Should not be a difficult problem. Why do I keep messing it up? Because I'm trying to go too fast, probably. Normally when I go fast, I'm fine. And it's like I want to restart it, but I'm going to do the exact same thing if I restart it. But I didn't show my work clear enough to check myself. That's brutal. That sucks. Well, I guess the bulk of this video is just going to have to be this problem. I think I might just have to do it all again. Or should I try to check and see what I did? I mean, the cosine of theta is 1/2, so that does become 3, so that becomes 13. Did I even have it divide by 13 here? I did. It was a negative 13. And that must mean the other thing is are negative. But the other thing is only one thing. So it does make sense that that would be negative because it's subtraction on the other side. But that's just that one thing. It's 54. Is it 6 times 8? 6 times 8 ain't 54. 6 times 8 is 48. Oh my gosh. So then this 2 times 56 was, whatever it was 108. Now it's 2 times 48. That's 96. So it's 9600 root 3 pi over 13. 9600 pi root 3 over 13. And it's negative. Wow. So that was just showing, I mean, that's an example of how it can get really hard. You've got to go really back in the back of your brain to find your whole like library of equations you know. So you want to use Pythagorean theorem here, but it's not a right triangle. And so if you need those sides, I guess the only way to do it is law of sines or law of cosines. And yeah, it ended up being law of cosines. That was tough. That was a tough one.